We're looking at section 2, multiplying monomials, and we're going to go ahead and work through a few different examples here. So we're going to start with this one. We see 6b cubed times 2b. The parentheses mean times. Now, what's a little bit tricky about this problem is the way that it is written. If I were to rewrite it in a way that's a little bit clearer, I would rewrite it, and I want you to do the same, as 6 times b to the third, because 6b to the third and 6 times b to the third are the same thing. And these parentheses, since you would normally distribute, but it's just a one group inside, one group outside, it's really just saying times 2 times b. And because we're dealing with exponents right now, just to clarify what that b is, I'm going to write b to the 1, because anything could be written as something to the 1 power. Whatever it was, it is times itself just once. So b to the 1 is a little bit clearer to work with. Now I'm going to highlight my number parts because I want to combine those first. I think it'll be a little easier to work with if I do that. So I have a 6 times a 2, and 6 times 2 is 12. So I'm going to write that out front. Then I have b to the third times b. And I know the temptation is to see 3 times 1 and say the answer is 3, but let's go ahead and write this out. B to the third, if I were to cross it out and write out at the end what it really is, it's b times b times b. And each of those is really a b to the 1. So I have a b to the 1 times a b to the 1 times a b to the 1 times a b to the 1. I have 4 b's being multiplied by each other. So I'm going to write this as b to the 4th power. The shortcut would have been to say I see a 3, I see a 1, 3 plus 1. Even though I'm multiplying the bases, I'm adding up how many times I'm doing multiplication. That's where I get b to the 4th. So this would be my final answer. Let's go ahead on down to number 15 here. We are going to have a power of a power. We're going to do this 2 different ways. We're going to do it the long way first, and I want you to write it out the long way because you'll see that, and then I want you to see the shortcut so that you can save time on some of these problems if you learn that shortcut. So we have ab to the third all to the power of 6. So we're going to write out the inside part that I highlighted, ab to the third, times itself 6 times. So we have a b to the third times a b to the third, that's 2 of them, times a b to the third, that's 3, a b to the third, that's 4, a b to the third, that's 5, a b to the third, that's 6. So I have all 6 of them. And like we were saying before, writing those a's as a to the 1 might be a good way to keep track of everything. And now I'm going to combine my like terms. I'm going to look at one of them at a time. I'm going to look at the a's first. So I have an a times 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 an a. That's a to the 6th. Then I have a b to the third times a b to the third, b times b times b times b times b times b. I'm really adding those exponents. 3 plus 3, 6, plus 3 is 9, plus 3 more is 12, plus 3 more is 15, plus 3 more is 18. I have b to the 18th power. And that is going to be the final answer. A shortcut to doing problems like this, if you want to use this in the future, is to say I am going to multiply that exponent that was there before, and I'm going to make sure I write that a to the 1 so I don't forget about that one, and multiply the exponent. 6 times 1 would be 6, and that's where we get that 6 right there. 6 times 3 would be 18, that's where we get that 18 right there. So that is a nice shortcut you can use if you're careful with that. And we'll use that in future problems. We'll show where some of the issues can come up with that. Moving over to the neighboring problem right here, we see negative 3 times r to the 2nd times a to the 3rd times t to the 2nd, all to the 4th power. So I'm going to take this whole thing to the 4th power. We could write it out times itself 4 times, but we're going to see if we can use that shortcut this time and save ourselves a little time. One thing I'm going to recommend that you do whenever you see a negative number inside of these problems like this is I want you to wrap that up with its own set of parentheses, because that reminds you that negative 3 is an entire entity in of itself. You have to treat that as a whole thing. You can't treat the negative as its own separate thing. And we're going to make it to the 1 power, because everything else has an exponent. It's not to the 0 power, that's something totally different. It's actually to the 1 power, so we want to write out the number 1 above that, just like this. So now I have -3 to the 1, r to the second, a to the third, t to the second, all of those to the fourth. And when we do that, we are going to take that times 4. That power is going to be 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 times 4. And now we've used up that 4 exponent out there. It has been applied to everything inside. So 1 times 4 is 4. So -3, keep that in its parentheses, don't let that go, to the 4th power. R to the 8th power. A to the 12th power. T to the 8th power. If you were to plug this part in your calculator right here, a number of you would get the number -81 in return, because you may not be careful with the parentheses. If you are careful with the parentheses, you will get +81. If you're wondering why the difference, it's because if you were to throw this into a calculator, like this little symbol is going to be the power symbol. If you're looking for how do you take something to the 4th power, it's going to look like that, a little upward arrow pointing device. Your calculator knows order of operations really well, and it's going to say, I'm going to do 3 to the 4th first, which is 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. And so it'll do that first, and then at the end it'll plop on that negative, because it'll say subtraction comes later than exponents and when we're doing PEMDAS or when we're doing our order of operations. And so you'd get the wrong answer of -81. Instead, what you want to do is make sure you use those parentheses. So -3 times -3 is +9, times -3 is -27, times -3 is +81. And when you do problems like this, I want you to clean it up and get that number to a single number. So we'll have 81, r to the 8th, a to the 12th, t to the 8th. And these letters don't combine because they are totally different. So that is your final answer. Let's go ahead and do one more example here, a nice complicated one. So that way you're not left on your own for this one. We have this entire group over here, all to the 3rd power. So we're going to go through and make sure everything has an exponent right away. We have a 2 to the 1, and I'm going to do the same thing with that 2 out there to the 1 power as well. So I have 2 to the 1, m to the 4th, n to the 4th, p to the 2nd, all to the 3rd power. You'll notice that I focused on this entire group to an exponent first, because when we're dealing with order of operations, powers come first, and we want to make sure that we deal with that little 3 out there right away. So again, we could write that out, that whole thing out in orange 3 times, or we could just use our shortcut of saying power of a power means we multiply each of the exponents by that power outside, which is 3 in this case. And when we do that, I'm going to rewrite the whole problem over. So out here I have 2 to the 1 times m to the 3rd times p to the 2nd. You'll notice I'm inserting those time symbols again, just because it helps me see it better. Then I have 2 to the 1 times 3, which is 2 to the 3. I have m to the 4 times 3, which is m to the 12th. N to the 4 times 3, so n to the 12th. And p to the 2 times 3, which is p to the 6th. And once you get things to this stage, now we're going to start combining things. We're going to look at what's all being multiplied. All this is being multiplied by each other. And we're going to look at what things share common traits. We have a 2 to the 1 and a 2 to the 3rd. Since we are multiplying the bases, we are saying how many times did 2 get multiplied? 2 times 2 times 2 times another 2, so 2 to the 4th. I'm going to cross them out as I go so that I don't lose things or forget about things. I have an m to the 3rd and then an m to the 12th, so I have m times itself 3 times and then 12 more times, which is going to be adding up to m to the 15th. I have a p to the 2nd and a p to the 6th, and that's going to be a total of p times itself 8 times, and then an n to the 12th. This first part right here, 2 to the 4th, I do want to get that down to a single number. So 2 times 2 is 4, times 2 again would be 8, and then a fourth time times 2 is going to be 8 times 2 is 16. And so I can do that in my head or do it in a calculator. I'm going to get 16, and everything else is going to stay the same. M to the 15th, P to the 8th, N to the 12th, and all of that is multiplied together.